And we're live. Hello there, this is Toby. I'm going to continue on my quest of building a deep zoom debugger. Deep zoom post-mortem debugger is what I'm calling it. I'm actually getting very excited because we're getting close to the place where I feel like we're actually able to give some impressive demos of this thing. Let me So I'll give a very short demo right now. So this is the user interface for this debugger, and with a Google Earth-like user interface, it's a primarily zooming user interface. You can zoom in by scrolling with your mouse wheel. Um, this is and it works in levels, much like Google Earth, where you can zoom in very low level, or you can look at the code from a very high level. So at this level is very high level. That's a program, and the program's entry point is main. You zoom in, you see the source code within main, but as you can see, there's a function call within somewhere in here, and you can zoom into that function call, and then that lets you see the source code within that function. In this case, it's the Fibonacci sequence implementation, and it's been implemented in a recursive way. So then this function has nested function calls within itself. You actually get to see the values that are the concrete values that are being set. Whenever you have a variable assignment, you can see the value that got assigned to that variable. I'm still debating where to put this information, whether it should go on the right side of the source code or maybe just under it. I think I've tried both and play around before I decide on that. You can also, whenever there's a return statement, you'll also get to see what the value that got returned was. And you can zoom in to zoom in even more if there's nested function calls. I think this is the impressive part that that would perhaps give people the wow effect. It certainly gives me this feeling of awe whenever I see this, being able to zoom in like that. So if you zoom in all the way into the base case of this recursive function, then you'll see that, oh, it actually hit the base case and it's just returning a value. The lines of source codes that you see is not every line in the function. It's only the ones that are executed. I had been considering, and I still am considering, maybe I should show all of the source code and then just gray out the lines that were not executed. However, I also really like this way of this rendering. This is actually a program slice, which is kind of a thing. Program slicing is a thing, even though it hasn't made it to the mainstream, but program slicing, the idea of only taking a sub-slice of a program um, to give you a simplified view of a program. That is actually a technique that's been heavily researched in computer science, and it was a technique that, with the aim of making programs easier to understand, and I sort of inadvertently, not totally realizing it, kind of stumbled onto this technique as well. I kind of like that you see a simplified view of the code rather than every single line of code. You only see the lines of code that got encountered during its journey, so to speak. Okay, so this is where we are right now. Um, right now, what I'm thinking of working on is add a couple of new features, and then after that, perhaps do a bug fix. The feature that I want to add first of all is I want to add this feature of whenever we're looking at the function and the function has these parameters, I want to display the value of the parameter that it got. That should be very easy to do given the infrastructure that I have currently. Second thing that I am thinking of doing is for this program it might not give you all that much, honestly, is whenever you have a function call expression, also display the value of the function call expression. And I guess for this case, it would be like, in addition to showing you, whoopsies, let me open up my screen brush application. Okay, so in addition to showing you the value of fib1 that it got, which was 5 as it shows here, it will also, for every single call expression to a function like this, I'm thinking it also shows you, hey, fib5 equals 5. In this example, it doesn't help that much because we see that the output of that is directly being assigned to that. But you could imagine that we didn't bother, the programmer didn't bother like doing this step, and instead they just wrote return, not equals, return fib of 5 plus fib of 4. If they had written that, then it would help to show here in a different color. Hey, you know what? The fib of 5 was 5, and then fib of 4 is 3. It would be very helpful to be able to show that, and maybe, I'm not sure, maybe we could display it inline down here. I don't know, I kind of have to squish this a little bit in, not sure, or maybe like have this so like, hey, that is actually 5, and hey, that is actually 3, or something like this. A vertical equal sign, is that possible? Can we have vertical equal signs? Do you think vertical equal signs make sense? What do you think if I do this vertical equal? Don't know. You don't know? Okay. Vertical equal signs, yes or no? Maybe we'll have a vote on that later. Okay. Okay, so those are the two things. Let's work on this guy first. This guy should be kind of straightforward. We'll say like n is equal to 6. Whenever we have a function, it's got a parameter. There's some refactoring here that I might want to do, maybe, before attempting this. Although I'm not 100% sure. I actually think it might help to restructuring. We won by checkmate. Awesome. Wow, that's a good game. Okay, so currently, let me think out loud here. So currently, the way that this text has been laid out is we got these text boxes. We got text boxes rendering these line numbers here. So each line number is within a text box. and yeah, and these are text boxes that were sort of defined by a fitbox algorithm that I've written. These lines of code, they are also reside in a text box, but let me change it to the rainbow color actually. So these, ooh, okay. So these lines of code are also residing in a text box. We actually have a container box that contains all of the line numbers currently. We also have a container box that contains all of the lines of code currently. And each line of code is contained within a text box. Now this one is special because it's got a call expression in it. And whenever a line has call expression, it's got an extra horizontal container box, which has 3 text boxes in it. 1, 2, and well, 3. The middle one here is the text box that's representing the call expression. So that happens for this guy as well. So yeah, so we got these text boxes that look like this. And then here is another text box. Here, this one, there isn't another container box because there's just it. And then there's another text box. I don't know if it may not have to stretch all the way across. If it's short, if the text is short, maybe that's the text box like that. And then over here we got another vertical container box. Let me try to draw good. Vertical container box, and the blank lines actually have a text box that contains a space in it, so that it reserves vertical space here. And then these lines have text boxes like that. And then finally, this whole thing, this whole thing is in one gigantic box. So the concept of the boxes is kind of a little bit like HTML DOM elements. And there's another box here, I think. Right now, what I'm debating is whether this is the best layout. Because I could have laid this out differently. Alternatively, I could have said, let me think about it. Alternatively, I could have done it like this, where there's one line, and then there's one text box, a second text box, and let that be done. A second line, and so forth. Now, in order for this lining up to happen right, and then these code to line up right, I kind of have to make sure that each of these texts have the same number of characters in them. With the vertical box approach, that's not important. So that's something that's nice about the vertical box approach, I suppose, is that the lining up on will happen right. So if I had a line here, for example, with a text box that just has one character in it, and then this string here in it, and and then I have another box that looks like this, then this box would not be aligned with this box, which maybe that's okay. Honestly, that's kind of a design choice. Like, we could potentially say, visual separation can be achieved with color as well. So we could say, hey, n equals 1, just put it here, and then here, yeah, we could just say, hey, fib1 equals 5. This could move in closer even. There's no need necessarily that these guys line up. Not sure. Again, something that I probably need to try before I make up my mind. So right now I'm a little bit undecided. But one thing that would have been made easier with this horizontal line approach is if at any point in time we felt like inserting some extra rows, it's actually quite easy to do. If with this horizontal line approach, if the way we're doing it right now with the 3 columns, we kind of have to make sure that the contents of the boxes within all 3 columns are lining up by adding the same number of boxes within each of the 3 boxes right now. And that's a little bit tedious, I found, to keep them in sync like that. So I'm a little bit torn on how to do this. Have I checked in my code? Have I checked in my code? Okay. I have modified my readme. So perhaps we give, because I want a safety net. I want to be able to go back if I make this change, if I end up not liking it. I'll just say save. Okay. And there's also another let me think. Yeah, you know what? I might have a try at rewriting this function, this get code box function from scratch. This is actually more work than I was intending, but I think it might end up being worth it. So I'm gonna try it. So let's do this. I'm gonna comment out the existing code actually, and then kind of write this whole thing from scratch. I think this approach will end up simplifying this code, and it might simplify the code also simply because this is I'm doing it the second time, and I benefit from the experience I gained from the first time doing it. Okay. I think this time I'm gonna say the outer box. Let's still have an outer box, but the outer box is going to be vertical. I might not even make this outer. I might just create this outer box at the. Well, no. Let's do it like this. I think there's a part of me that doesn't like doing array.push to push into this array because that's mutation. But a different part of me thinks that if I say outerbox.children.push, that makes it more explicit that you're adding to the outer box. Yeah. So let's go with that. Okay. Okay. And then I guess there's a thing that in the last episode I think I said that I was gonna change. So previously I first collected all the call expression nodes within the source code, which is basically these things that have boxes around them. They're call expressions. They call another function. They're function calls, right? These are called call expressions, and call expressions open up a new scope, which you can zoom into. So those guys we want to treat as a special thing, and we draw these boxes around them. And yeah, we do additional net render. We do additional, like a potentially a nested recursive call to render this box inside here. So we collect these things. Currently we find all of them first within this source code. So like there's code that loops through all of these lines of source code in terms of ASTs, and they're like, oh, this is a call expression, let me collect that, and so forth. And then later on they collect it into an array, and later on it pieces them together with the lines that have them as it's looping through each line of source code and rendering them. I'm thinking now that instead of doing that, I just loop through each line of source code, like invert it. So while I'm looping through each line, I loop through this line and try to find a node on this line that's a call expression. And in this case, there isn't. So it tries to find a call expression on this line, and in this case, there isn't. And then try to find a call expression on this line, which it is going to find one right here. And it's like, hey, here's a call expression. And then you do your thing. So I'm planning on inverting that. And so if I do that, that's going to look like, let's see, I'm gonna go through the current entries. I think I'm gonna steal these few lines here. Boop. Okay, so we're gonna loop through the current entries. The current entries are the lines that each line of code that was encountered. So this line, oh, it executed this line. This line, oh, it executed this line. Each entry will have a line of code that was encountered in the execution of the program. But I guess before that, I should add this first line, which is the function name, which I did that separately, I believe. It was probably... where is it? Code line? Where is code line? I would think it would involve the function name. I totally didn't find it. That is a little strange. That's okay. I think I'm just gonna go slow here, and I'm just gonna loop through each entry. I'll just build it up. Not worry too much about how the original code was constructed. So I might not even worry about the next entry right now. So each entry, each historical entry. So if you're wondering what an entry looks like, or a history entry looks like, it's actually one of the objects in this history file. So it's an object. It will have a line number, it'll have a stack, it'll have a heap. Body, you can ignore body. Not super important in what we're doing. But the stack is an array of stack frames, which contains local variable information of each function that was called, because the function is in the process of executing at that point. So an entry has a line number, which is line. Yeah. And with that line number, we can get into the line of code, because we're receiving the code of that function here, which I'm gonna split, which I already had the code to do that, so I'll just grab. I split the code into lines of code, and then I can use this line number to get in there. Any help with the internet? Yeah. Hey, also, probably you shouldn't be on the screen all day, right? So do you want to maybe do something else in a moment? What's another thing you can be doing? Okay, so now the line numbers in this history file are one indexed. So, but this array of code lines is going to be 0 indexed. So I'm going to subtract 1 to index into it, and then now we get the code line. Okay, now get the line. Let me close the door. Okay, so now we have the code line, and we can add this as a text box, maybe. Yeah. Oh, well, there's the line number as well, but yeah, let's put the line number. So line number box is a text box, let's say, and as such, it has type of text and a text of, let's say, the line number, actually, which should be entry.long. I'll just inline entry.line here. Okay, so that's the line number box, and then we'll also have a code line box, which is also a text box. I think we have a color, which is like line number color. I think I have that defined at the top of this file somewhere, so I'm gonna go there. Line number color, yeah. And then code line box is also a text box, and its color should be code color. It's code color. And then we're gonna push both of these boxes to the elder box dot children. I think this exercise is good because it'll kind of be instructive as to how to use this sort of fit box framework. Okay, so we push the line number box in the code line box into this outer box. Let's just see what that looks like right now. It will definitely be less good than it was before, but you know, I got stuff source controlled, so I'm not worried about losing code right now. Oh, got failure to compile. Let me see, I got a text message. Oh, okay. 232. Entry, oh, let's see. Number is not assignable to type string on line 232. Oh, because line is a number, so I'm gonna convert that to a string. And then we said cannot find name call expr text boxes, so that doesn't exist yet on the last line. So but it's needed by the rest of the code. So for now, I'm gonna fake it and say that's an empty array. I think that should be okay for now. Okay, so if I zoom in now, I get this, which is not ideal because we get these repeating two lines. Previously, the way that was avoided was oh, I should probably explain why that happens first. So if you look at the history file here, oh, there is. It's just, I guess the problem is that this print. Yeah, let me explain why this happened. It's actually wrong that this is above this one, so that's a separate bug that needs to be fixed. Maybe I should fix that first. Let me try. Oh, this is a vertical box. Oh yeah. So I actually want a horizontal box to contain these two boxes. Yeah. So we're saying there's a vertical box. If this is laying things out in a vertical way, then and we want the line number and the code line number and the code line here to be laid out horizontally, we actually need another box here to contain these two boxes. So let's do that one first. I'm gonna call this a line box. I might just inline this honestly. So type is this is a container direction horizontal children, and then the children should just be these two guys. Maybe I just keep them and then just inline these two guys inside the line box, and then I push the line box into the outer box. That's what I do. Okay, so now we got this, but this is still undesirable because we got repeating lines. The reason it's got repeating lines is during the execution of the program and the language runtime is capturing the state of the program at every single line. I designed it specifically to do a snapshot, take a snapshot whenever there's a function call on a line like this. I had to take a snapshot before calling this function and then take another snapshot after calling this function. And that was done so that in the previous version of the debugger, the step debugger where you have to press like go to the next line, etc. We could, after drilling down into the function and then it comes back up, we could pause on this line again. Now this version of the debugger doesn't need it, but that doesn't mean we want to completely get rid of the previous version or the other version of the debugger, right? So we don't necessarily want to change that. So what we could do here is just eliminate the duplication here. And the way we did that previously was say, hey, let's look at the previous entry, and if the previous entry's line number is same as this entry's line number, we're gonna skip. So if if next entry's line number is same as mine, I'm gonna actually skip rendering this one. I think that will get rid of this. Yep, and that's gone. Okay. So we got our lines now. I think we can probably even, no, we can't drill in because we need to get the boxes. Okay, so let's work on getting the boxes. So to get a box, currently I have made this guy. Now I'm gonna, yeah. Okay, that just gives a type to these call expression text boxes. That's fine. So in case you're not, you don't understand what this means the type of call expr text boxes it's an array of objects where each object has an expr property. The type of that is any, we don't care, and it has a box property, the type of which is a box. So we're going to collect stuff into here as we find things that happen to be call expressions. And the way we can find that is by using this function that I've made very, very recently. When should we do it? Maybe here. Yeah, let's do it here. Yeah. Yeah, this is fine. So we find the unassignment node. So in the previous code, we found, and we're gonna do that in the new version of the code too. Found for all assignment nodes, we actually want to display the variable value as a result of the assignment. So this is why that is doing that. But the other thing we want, I'm gonna comment that out for now, because the one I care about right now is actually the call expression, call expr node. And that guy is actually, yeah, just called call expression. Okay, so we're gonna get a call expression node, and if there's a call expression node, then we're actually going to split the line, the code line box. Where's the code line box? Oh, that one. We're actually gonna split it up into 3 chunks, or actually as many chunks as there need to be, in fact. Hey, what's up? What are you doing? What do you want to do? Maybe you don't want to draw? You don't have school anymore?
I have Chinese at 3.
Chinese at 3? Okay. Don't know, maybe like draw something or read a little bit too, not just play. Why? Not too much screen time, that's why. Huh? What do you say? Okay. Alright, sorry about that. Get back into this. So we actually, if we there's a line of code that is say something 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 and then call some function and then something else. We actually wanna split it into like multiple ones, multiple boxes. One here, another one here, and then another one. Three boxes. We're gonna split this guy into 3 boxes. If there's actually 2 of these, we actually wanna, although the code doesn't do that right now. If there's 2 of these guys, we actually wanna split it up into even more slices. We're gonna split it. There's one here, another one for this call expression, another one here, and then another one here, and so forth. So part of me actually wants to go ahead and support this multiple call case right now. Maybe what we do is instead of making one this guy, maybe we just keep appending so to this line box. Maybe instead of calling this line box, call this horizontal box, H box. Or line box is actually okay. This is the line we're rendering into. Let's start with just having a line number in it, and then we'll append more to it as we need. Yeah, let's do it like that. And then we will say, hey, I need to do line box dot children dot push code line box if we see fit. So okay. So here I'll say see if there are call expression nodes. And then we'll say, well, if there are, then we need to do this split thing. How do we do that? Let me think. So let's see. For each, let's make a maybe make a little for loop. So this will be plural actually. When I use the terminology node, I mean AST node. AST node, which AST stands for Abstract Syntax Tree Node. So we're gonna loop through each node. Let's call this call expr node to match the terminology. So for each call expression node, we're gonna say probably add more lines into this line box, add more boxes into this line box. So, but there could be a case where there aren't any nodes at all. And maybe what we do then is have a cleanup or wrap up after the looping so that, okay. So right now I'm thinking like if we had a string like this, and the string was like, hey, value equals f of x, something like this. This is a string, let's say, like this. Let's just this is a string, and I'm gonna visualize it as an array of characters, which that is what a string is. So and we could put little index numbers in here: 0, 1, 2, 3, 4, 5. Okay. You can say, well, initially we'll keep this sort of current position index maybe, and it initializes to 0, which means it's like pointing to that, right? Pointing to the first cell. And so if there happen to be no call expressions at all, then we'll say when at wrap up time, we'll just collect all of the strings starting from whatever the current position is, and they'll grab all of the strings. So from the from the current position, which is 0, until the end of the line, that line, we could line that length or whatever, or we could do like line dot slice the current position. Then that grabs the rest of the string. So we'll get the whole string, and then we'll put that into our line box, and that'll sort of correctly wrap up even if there weren't any call expression nodes found. But if there are call expression nodes found, then what we're gonna do is we'll find a call expression node here, right? Like this is a call expression node, a sen. Okay, and and there could be another one, I guess. Maybe like there's another one later or something. But let's say in this example there isn't. But we'll loop through them and say, oh, I'm gonna actually, when there's a call expression, I'm gonna, first of all, I'm gonna take whatever comes before it and then enter it into the line. Secondly, I'm gonna enter myself into the line as well. And then thirdly, I'm gonna move the cursor position to the to after me, which would be actually 6. So move the cursor position over here so that the next time when it's time to wrap up, it'll actually know to grab this. But since there's nothing more, you actually don't have to. But if there were like extra strings here, that should be grabbed and then appended to the line box as well. And I feel like that should work. I'm gonna try it. I'm gonna try this algorithm. hope that it works. So we're gonna have a current position pose. We'll initialize it at 0. This kind of abbreviated word, some people frown upon it, but I don't know. I think it's fine. If it's localized. I'll implement the wrap up first. So we should grab line that slice curve pose. If you don't provide a second argument to slice, then it's assumed it goes to the end of the string. And this is the thing. I guess I'll say if that guy's length is greater than 0, then we will do it. I'll call this guy rest. Okay, so if there's something in rest, then I wanna do line box dot children dot push a text box. Color would be color. Okay. Okay, and then as we're looping through these call expressions, we're gonna say first we want to the call expression node is gonna have an AST node, and to show you what an AST node looks like, can't do it in this one. I'll just draw it out. It'll have a start property. Yeah, I'll just tell you what it has. It has a start property which has a line number and also a column number, actually, which is call, I believe. So start index is call expr node dot start dot call, and index is call expr node dot start dot end dot call. There's a start position and an end position. Both of them have a column number. We already assume they're on the same line because that this guy restricts that. It will only find nodes that are on this line. Okay, so now we're gonna say we're gonna grab I'll say previous code is line that slice curve post until start index. That's the previous code, and we want to add that to the line box. And then code color. Okay. Because that's the color that we are gonna render all code. And then we're gonna grab the trunk that starts at start index and ends at end index. So let's do line.slice start index end index, and this is the one that corresponds to our call expression. So I'll call it call expr code. And I also want to push that into the line boxes children. Oh, this should be text, not test. Text. Can't help myself. Call expr code. Color also be code color, I suppose. And then we're gonna move the cursor position up to be end index, I believe. Yeah, I hope that's right, but if it's not, then we will have to debug it. So let's see what happens. I don't think that worked. It might be a compiler error, maybe. Cannot find name fun node on line 250. Oh, fun node. Let's get that guy initialized. So previously that's how we initialized it. Sure. We're just gonna steal that code and have it. Not too hard, I don't think. We already have first entry. We probably don't even need to pass in first entry, honestly, because that's just that. Yeah, I have a feeling we don't need it. Current entries is index 0. That should give you the first entry. And then, yeah. Now I might just delete that guy if we can. Duplicate identifier first entry. I think I'll just go ahead and do this before I forget. Okay. That compiled. Let's see if it runs. Okay, I'm gonna get rid of this. Okay, that totally didn't work out as I planned. So we'll need to debug it. I don't, okay. We have an error, which is very helpful actually. So object is not iterable. Fitbox 389. Get codebox. What now? Get codebox index 255, line 255, 255 here? Oh, as in whatever that returned, it's not iterable? Oh, I see. No? It should be iterable. Oh, okay. Oh, okay. This function returns an array, but then I immediately just grab its 0th element. So I didn't mean to, but the previous code did it, so I copied that code without thinking. So yeah, if I just don't do that, it'll probably be okay. I still have this. Oh no, now it's completed successfully. Let's see how it goes now. I'm gonna move this in. Okay, let's try this. Oh yeah, I mean a little bit better. That's not what I intended, but I guess we can keep trying to fix it. Line box. So what do we have right now? The line box is a horizontal box. It should get appended to this outer box at some point. It does it here. Let me see. I think there's definitely something wrong with my algorithm. So maybe what we do here is console.log the result of the line box and just inspect it, because most likely that is in the wrong state. So let's see. All right, we have 3 children. Oh, that's one of the box. No, this one has 7 children. Yeah, this one is the one that's messed up. Has a line number 14 and then some white space and then print fib7 and then empty string and then another fib7 and then a closing parenthesis and then another print fib7. That should not happen. So that's wrong. We're gonna need to fix that guy. Oh, this line, this chunk should go. That doesn't belong here because it's assumed that after this loop and this wrap up, then it should have sort of put all of the code on to the screen. Okay, so we have less junk now, but we still got a little bit of junk. So now let's look into it again. Okay, so I think it should have chopped it off at here over. Is it this line number is correct? This empty space I think is correct, but it should have chopped it off right here, and then we should have had this. This fib7 is probably also correct. It's just this chopping off of this piece, maybe that's incorrect. Oh, I see. There's a call expression that is the print function. I see. I did not account for this case when. Well, there's a couple of things going on here. One of them is we have this nested call expression thing where it's a call expression inside of another call expression. So I didn't think to handle that case, but we do need to handle that case. The second problem is I actually don't want to drill down to the print function here at all. Don't care, because that's a native function, not a user-defined function. So previously we just had code to filter out the print functions, and we only care about user-defined function calls, and that should still be done. But having said that, it is still possible that we have nested function calls like that, where both f and g are user-defined. We still have to figure out that case as well. I can either solve that problem. Well, I should solve both problems. Let me solve this one first, of filtering out the built-in, filtering out the built-in functions, and then perhaps we can solve this problem later when we actually create a scenario where that happens. Did you win? You did? Oh, you went on time?
Yeah.
Awesome. Okay, so yes, that's the plan. So here I actually want to say find nodes of type, I guess. So if it's, so I'll just say if the call expert node is user defined, which, how do I tell? User defined functions. I somehow get this array of user defined functions here. Okay. it might help to get the user-defined functions pre-computed and passed in for optimization's sake, for performance sake, but that hasn't occurred to me to be a performance problem, a noticeable performance problem at the moment, but that's something we could optimize for. So this AST means the whole AST, not just the function scope, but the entire program. So it's going to go in and search the entire program for user-defined functions. If it were a large program, maybe that takes a while. Not sure. So I think I'm gonna go move this line in. So we got the names of all of the user-defined functions. So we only care if here, we only care if well, if the called expression, no, the function name of the call expression value, you have to do that value to get the string, is in there. Is it includes? I want to make sure that's a thing. Yes, okay. So only if it's included do we do this. Or I guess if it's not included, then I'm gonna just continue. That reduces the amount of nesting. Okay, so if I did this, then let's see. It might be fun underscore name. So we could look at, I'm gonna head over to the play language repository and look at what a call expression looks like. I think it might just be called fun underscore name. Yeah, it's call underscore name, not camel cased. Okay, so there it is. Yeah, that looks correct to me. Okay. I'll comment this out. So I think I can probably, given this, well, this is the, this belongs in here. So call expression text boxes. This is the call expression text box. So I'll call expert text boxes dot push. I think it actually wants a, first of all, the expert, which is the call expert node, and then the text box, which is called box, like that. So this guy, when it collects these two things and then returns it back out later, all the way down here to be used, that's when it will recursively allow zoom in. Let's see if that works still. Yes, it does. Nice, nice, nice. Okay, this is Beautiful. And then I can zoom in again, and so forth. Okay. So now I'm thinking we should probably clean it up. There should be this def main here to show the how did I do this originally? This is very strange. I can't find the code that did this. Is it here? Got another win. But you won this one. Code box. It would be the line. Code line number box. Code box gets a code line. Oh, it gets the code of the function, maybe? No. Function node. There. It uses the function node. It gets the starting line of the function node and says that's the first line. Yeah, that makes sense. Okay, so I'm gonna do that same thing. Maybe do it in a slightly cleaner way if possible. So I think I'm gonna make so here I'm gonna write a line of comment that says go through current entries and lay out the code line by line. But before that, I'm gonna say I'm gonna render or lay out the function signature, which comes from the function node, because the function node has a start line as well. It's an AST node just like any other. And we can use that to go into the code lines. Wait, does that work? Yeah, that should work. Go into the code lines. I'll call this the function sig line. Sig, not sign. I'll spell it all out. Fun signature line. And here I'll append a line onto the outer box. Let's just do it one line in an inlined way, maybe. Push push a container box. Container whose direction is horizontal, and then the children are there are gonna be 2 text boxes. Later on there's gonna be 3, but the first one is type text. Text is fun signature. Oh no, I actually want the line number, which has to be converted to a string, and then color should be line number color, and then not a text box. This time it should be the font signature line. And color should be code color. Let's go with that for now. There we go. Yeah. Yes, sir. Yes, sir. And then we can drill in. There should probably be a little bit of space after a line number. And also, an advantage of this approach is that I can actually squeeze in lines if I feel like it later. I want another extra line. I could just squeeze in a line, but I do have to sort of keep the line numbers or the lines of code aligned, which I'm thinking of just using the padding stuff. So I could do maybe like what is the greatest line number of all? Oh, we can't know that until we can't know that until we encounter the entry. The entry with the greatest line number. So let me grab the largest line number. For using with padding, I guess let me hard code that first. So let's say line number width. For now, let's say it should be 3, but this will need to be calculated later. But here I can say pad. I think I can say pad start or pad end. Should we do pad start or pad end? Probably. How does Adam do it? They do it pad start here. So pad start would be the padding goes before the number. Pad end would be it goes behind the number. So I'll follow what Adam does, which is pad start. Pad start. So say pad start. And I'll do that for this guy as well. And then there should be some spacing now. Did not appear to work. No, it worked. It's just that I need some additional spacing in addition to that. So let's do maybe just 1 or 2 spaces. That's pretty good. Okay. I kind of like the and better, honestly. So I'm gonna deviate from Adam actually. So if it were pad end, then there would be this vertical line that lines up. Yeah, like that. Yeah, it's debatable which one you like better, which one you should like better. I don't know. But anyway, so this zooming works again, and the line numbers work again. The thing I want to make work next is the variable display. So we made that work already last time, but I'm gonna do it again. But maybe I'm actually thinking maybe make it like sort of have it on the line underneath it in a peach color, like have it in a line underneath it, maybe even with a different font size, possibly. Although if you had a different font size, then I can't do that optimization that I was thinking before, but maybe that's a small price to pay. So I might say like n equals to 0. When you're looking at this n, you can sort of already see very quickly that n is equal to 0. And then over here, I may say, hey, fib1 is equal to, I believe this ends up being 5 or something. Don't remember. I guess what I have it doing currently is like this. Which is cool also. And I think these things don't have to be aligned necessarily. So I'm gonna try not aligning them and see how I like the look. So this will say return value equal to 8, like that. Let me close the door. Okay, so I'm gonna do this one just because that was my original intent. The new feature to add before I refactored or rewritten all this stuff. But so far I'm liking this rewrite. I think I think this rewrite is logical. Even though it still ends up being kind of tedious. Okay, so I'm gonna make an additional text box here. I might. So maybe I have an if statement here. I think I may need a function signature box to represent this. So I'm gonna get fun sig box. So this is a container box. I'm gonna have this fun sig. I'm gonna follow suit with this. I'll just inline this one actually. So I will have a fun sig box. And no. Fun sig box. I'll push into the outer box. And in the case that the function actually has parameters, and I think there's two ways to tell whether it has. One is by looking at the execution stack, Another way is by looking at the AST node. Function call, the call expression. The AST node has arguments, but the function definition, actually has a parameter list which you can loop into. And since we already have the function definition, that is this fun node, we can actually just loop through its parameter list. So maybe that is like for param of fun node dot parameters. We're going to, the param, I think, is going to be an identifier node, which will have a identifier. Look at a file that has identifiers in it. Or, I don't know. Go type identifier. It has a value. Right, so that is going to be the parameter name. Okay, and then the parameter name, we'll use it to look up the stack for the value of the parameter, which I think that is the stack. I think I should call the stack frame. It's more correct to call this because we look up the stack for its individual stack frame. So the stack frame has a variables dictionary, which can tell you the value of the parameter. Okay, and after this, we can just append another text box onto the fun signature box showing the value of the parameter. So I'll probably just do fun_sig box dot push dot children dot push a text box, the text of which is gonna be first the param name, and then equals, and then the value. Maybe put a space in front of it to give some spacing, and then the color will be, I think I might have to find a color for this. Variable display color. Okay, see if that works. I think that might work. Bam! Yeah, n equals 7. Yeah, love it. N equals 6. Oh man, that is so awesome. Yeah, I like it. I like it. Maybe slightly more spacing. I don't know. Although I kind of like this. Maybe like with a little colored box around it, possibly, to visually separate it a little bit more, possibly, or maybe make the font slightly different. But in any case, like, I like this, and this was the feature I wanted to implement at the beginning of this session all along. But now we should re-implement the features of, like, whenever you have a variable assignment, show the value that was assigned to it, and do the same with return. Do the same with return statements as well. So we'll add those back. So the way we did those was, let's see, how do we do those? this is return statement. So this was saying if there's a return statement, then I'm gonna steal this for the return statement. I'll steal both of these because all the logic required is already in there. This is processing for the call expressions, but then okay, it should happen here. So I'm gonna say display variable values for assignment and return statements. I'll paste this right in. Okay, I have this statement that grabs the assignment node. Okay, so this is saying if we found an assignment node, then we're gonna do this. But previously, we already have a stack frame, so I don't need to do that again. Previously, it appended to this variable display box. This time, I don't want it to do that anymore. We're just gonna push it into the line box. Yeah. Maybe use the same amount of spacing as this other one here. Where is it? Here. We'll figure out the spacing thing. And then here is this is saying it's either assignment node or return statement node, but maybe I'm gonna reduce the level of nesting because I don't actually think it needs to be nested like that. So just so here I'll say make another comment. Whoopsies. Okay. So for return statements, again, we just push into this line box. What is this? Oh, this is no longer needed. The appending of the empty box. That's a thing that got simplified due to our new scheme, which is great. Okay, let's see if this works. Yes, I think it worked. No, it didn't work. I got these undefined values. It worked for the return value. So var value, why did that not work? Stack frame dot variables var name. Stack frame, we did make a thing up here that was the stack frame. I did find stack frame. I did delete that line. This is the last stack frame for the first entry. Is that different from what it used to do? No, this is. Oh, it's of the next entry. Understood. Yes, it needs to be for the coming from the next entry. That's actually important. So call this next stack frame. Okay, I think that should do it. Whereas for the return statement, it was well, I'll also call this next stack frame for consistency's sake. Or perhaps we move this line out, although, yeah, whatever. Okay, so that works again. And so these are aligned, and these lines are not aligned with each other. They are sort of scattered, which I actually think is okay. Um, yeah. Okay, so we accomplished a couple of things. One is we actually rewrote the algorithm to lay out these text boxes. Um, the performance of this thing doesn't feel that great to me, but it's usually slower when I'm streaming, so I'm not super worried about it. But I also have a couple of ideas on how to improve the rendering performance even more. So and if I did something this time to make it perform worse, we could dig into that and solve it as well. So not super worried about that. Um, let's see. Yes, I like the way this is rendering. I might try like putting this orange text under the line instead of next to it. And take a look at what that looks like, and that should be fairly easy to do now with this new way of laying out this line. I'm happy enough with this new algorithm that I'm going to actually delete this code. Uh, it's never really deleted because we have checked it into source control. But that also means I can delete this function, which that code uses, which is beautiful. I like deleting code. This function is still kind of large. How large is it? 215 to 356. 356 minus 215 is 141 lines of code here, this function. So it's still kind of large. I might extract things out of it, but I feel like the process of writing this has felt very straightforward. So, so I think extracting should be easy to do. Okay, so right now I guess the other thing I said I was going to try is to, whenever there's function call expressions, I also write out the return value of that function call expression. Um, but I actually think maybe let me try moving these peach colored lines under the code line and see if I like that. Either one is an option, I suppose. Let me commit this code because we're at a pretty good place right now. I'll say rewrote and simplified get code box function. Let me check the stream quality. It actually says excellent condition, so great. All right, let's continue. So yeah, so let's try to move these variable display lines under the line instead of to the right of the line. So how should we do that? That's actually quite easy now that I think about it. And also given this new layout. So currently, so let's go into here. Okay. So we've changed the box layout to we have these we have a horizontal box that surrounds these text boxes. There's going to be one text box for the line number, a different text box for the code, and then a third text box for the variable display now. So instead of put this variable display, instead of putting it into the same line, we could instead just take it out, but instead add in another line that contains it. And with the proper spacing, I like the proper spacing to allow this to be aligned with this variable name, like that. So let's see if we can do that. So that would be for the function parameter. So let me get a line of comment. It says add function parameter value display. Okay, so here it adds a box to the fun_sig box, the function signature box, and we no longer want that. Instead, we want to add another line to the outer box. So instead of adding to the fun_sig box, we should just add to the outer box. Yeah, this is not going to align properly right now, but let's see what it looks like first. Whoops. Okay. We actually need, we push this box before we push the actual fun_sig box, so we should do that after. Okay, so that worked. But now, in order to get the alignment, we need some spacing to account for the amount of spacing for the line number plus the amount of spacing from the beginning of the line until we reach the parameter name, which we can use the parameter name. Let me think here. I actually may need to handle the spacing before reaching this loop here, I think. So perhaps we make a function parameter value display box. Fun param value display box, which is a container box, which is of type container. Direction is horizontal, and then it's got children. I'm gonna again push into these children, but this guy is gonna get pushed into the outer box. Okay, so before pushing each of the parameter values now, we're gonna add some indentation, and that indentation, I think, is gonna need to be dependent on what is the line number width, which currently is hard-coded, but later on we're gonna make that calculated. So cat end by that much, plus, wait, let me do, so let me add a text box here. Okay, and then we're gonna need to add the fun node, the first parameter. I guess I can I'll just say if fun node dot parameters length is greater than 0, then we're gonna do all of this stuff. Otherwise, don't even bother. Okay, and here we can assume there's a 0th parameter that way, and the 0th parameter start call, that's the column index. We can just say, what is that? I guess it would be that plus this plus 1 is how much spacing we're gonna need. Did that work? Yes, that worked. It lined up. Okay. That's cool. That's quite cool. I kind of like it. Let's see. I'll do it for these variable assignments as well, and we'll see if we like it. If we don't like it, we can revert because I did commit the code before starting this change. Okay. So the variable assignment here, we're pushing it to the end of the line box, but now we're gonna start a new line and add it to the outer box, similarly to this thing here. So I have a feeling I'll need this same calculation here, so I'm gonna steal this piece. Okay, I'll call this variable var display box, and it's gonna be horizontal, and this time it's gonna be based on this assignment node position. Yeah, and then we're gonna append it to this guy instead. Yeah, let's see that. Do one thing at a time. Test this one out. See if that works. Oh, we need to remember to append this guy to the outer box. Okay. Almost. Almost. I want the orange line to go be under the black line, and also it's indented too many spaces. So I think that just means I need to move this stuff until after this line. All right, let's try this. Yeah, I like this. I think I like this. Well, I don't know. You tell me. You tell me. I'll try both approaches, and it seems a little weird to me that this is like not aligned with the other lines. Let me do that for the return value as well. So for the return value, I'll do the same deal. Call this return val display box, and then I will want to do this to the return statement position, and then after this we're gonna wanna append it to the outer box. Okay. Seems to be a little misaligned, so I'll maybe just -1 here. Okay, so yeah. So now instead of on the right here, this information is inlined over here. And I feel like another one of my tasks, like this right now, the line of code here doesn't actually say fib4, but rather it says fib n-1, right? Like the original source code. Original source code actually says fib n-1, but this display the concrete value. I think that's nice in one sense, but in another sense, it's like we're increasingly differing from the original source code, and I don't know where to strike the balance right now. So I was thinking revert to displaying the original source code within this box, but then perhaps display the concrete one under it, and then also show the value, which in this case is 3, something like this. I'm not sure. Um, so if I were the developer looking at walking through this code, like following through this is quite easy. Okay, that's the bug, I think. There's a bug. I'm gonna need to debug that thing. Whoa. Whoa, actually this is not the bug that I originally saw, I think. Maybe I introduce a new one. Okay. If I zoom in here, no, I don't see the bug this way. Okay, so not 100% sure that I like this. I think there's something about it. It doesn't look as neat as the other one. Um, hmm. Yeah, it doesn't look as neat as the other one. But what's nice about this one is that the visual is not as wide. It's not as wide. You don't need as big a screen real estate to see everything. Yeah, it has more vertical. It uses more vertical real estate than horizontal. Okay. Yeah, I'm a little bit torn about whether to keep this or revert to the previous version, honestly. I think I'm going to take a screenshot of this and then revert to the previous version for comparison and maybe ask some folks which one they like better. And perhaps like check this in a branch so it's easier to get back to this version. So I'm gonna check out a branch. Let's call it inlined variable display. Okay, and then if I check back out master, then we should be back to the version where the variables are on the right. Okay, there we are. Okay, so now let me think. I think I would like to see the whoopsies. I think I would like to see. Let's implement the next thing I was planning to do. I think I would like to see this. Or perhaps this one first, maybe. I'm not sure. The problem is if the more information we add to the right side, then the more width someone would need to see all of this stuff. So maybe then we do go vertical and put it in here. So like, yeah. I feel like we should display it like first tell them that fib6 is equal to 8 and then tell them that fib1 is equal to 8 because this should have happened first before this in the evaluation order. So if this line look like return fib6 plus fib5, then on the side we display fib6 is equal to 8 and fib5 is equal to 5, and then we display rit val is equal to 13. We display these guys and stack them vertically like this next to this line of code, and then I think that would be helpful. And yeah, yeah, that actually isn't super easy to implement. So I think I'm gonna take a break before I embark on, on that journey. So I'm gonna stop this stream now, and I'll see you next time.